The first official photo of Saturn taken by the James Webb Space Telescope did not disappoint scientists. The first official photo of Saturn, taken by the James Webb Space Telescope in 2023, did not disappoint scientists. NASA's James Webb Space Telescope team has begun performing Saturn's first near-infrared observations. The mere observation of Saturn, the ring-shaped planet, one of the most beautiful and popular planets in the solar system, has already excited the public. The release of early images taken by James Webb's near-infrared camera was sufficient to generate exclamations. The above observation was conducted as part of the Guaranteed Time Observation program proposed by Professor Ray Fletcher of the University of Leicester in the UK. In particular, the above observation program was launched with the aim of detecting faint satellites and bright rings around Saturn to obtain important clues about the evolution of the current Saturn system and its past history, and included several long-term exposures to photograph them. For decades, probes such as NASA's Pioneer 11, Voyager 1 and 2, the Cassini spacecraft, and the Hubble Space Telescope have tracked Saturn's atmosphere and rings, but it is very mysterious when viewed with infrared light. At infrared wavelengths, Saturn itself appears extremely dark, as methane gas absorbs most of the sunlight that reaches the atmosphere. However, the ice rings remain relatively bright, making them look quite different from the images of Saturn we have observed so far. Because methane gas absorbs almost all the sunlight that falls into the atmosphere, Saturn itself looks very dark at this infrared wavelength observed by a telescope. However, it added that the ice rings remained relatively bright, showing abnormal appearance of Saturn in Webb images. James Webb observed the inside of Saturn's rings in detail. The new Saturn image of the James Webb Space Telescope, along with Saturn's signature satellites, Dione, Enceladus, and Thetis, accurately shows the interior of Saturn's ring system. Saturn's rings are made up of rock and ice pieces, and the size of the particles varies widely, ranging from smaller than a grain of sand to several kilometers. In particular, James Webb recently observed Enceladus and discovered a huge column of particles and large amounts of water vapor erupting from the satellite's south pole. Through this, it was revealed that Enceladus was circulating around Saturn, emitting a huge amount of water, directly supplying water to Saturn and its ring system. Using longer exposure, the team examined the thinner G ring and the wider E ring in detail, which will soon be released to the public with research papers. It was the first time that Saturn's atmosphere was observed so clearly in near-infrared rays. The Cassini spacecraft, which was already very close to Saturn, observed Saturn's atmosphere more clearly. This is the first time that Saturn's atmosphere has been observed so clearly at a specific wavelength of James Webb. What is unusual is that in the above picture, there is no stripe shape generally found in Saturn's deeper atmosphere. This is understood to be due to the large, dark, and widely spread structure of Saturn's northern hemisphere that does not follow the planet's latitude line. In addition, it looks similar to the large-scale circulation pattern of stratospheric aerosols shown through near-infrared observation of Jupiter. Although Saturn's ring, which shines like a glow-in-the-dark lamp, is the main character in the new picture, Enceladus, Dione, and Thetis, 3 of Saturn's 145 known satellites, are no less revealing. By comparing Saturn's North Pole and South Pole, you can observe the changes that occur in Saturn's seasonal changes. For example, Saturn's northern hemisphere is currently spending winter and the southern hemisphere is nearing its end. In particular, Saturn's North Pole is believed to be darker because of its seasonal changes affecting polar aerosols. To understand this, James Webb's spectroscopic observation is expected to be conducted. According to James Webb's team, high-altitude methane interactions and the release of tritium ions from the ionosphere will be identified. The jwst is designed to give astronomers a glimpse into the long-past approaching Big Bang time, allowing them to see the first stars and galaxies in the universe. However, as the new Saturn image shows, Webb telescopes can see objects close to Earth in this way. The $10 billion telescope actually took amazing pictures of Uranus and gave us a wonderful view of Jupiter and the polar aurora. In addition, JWST's activities have only just begun.